Hey guys, Ms. Gosling here. In this video, you are going to learn about Newton's third law of motion. By the end of the video, you'll be able to define and give examples of Newton's third law of motion. So before we get into Newton's third law, I do want to just really briefly give y'all a list of forces. And this is something we'll be coming back to in the next unit as well. So one way I can categorize my forces is by differentiating between contact forces and non-contact forces. You'll remember I did speak about this in our earlier video, right? We have some forces that only work if we are pushing or pulling on something. We have other forces that exist regardless of whether the objects are touching one another. So our contact forces, the ones that we'll be using pretty frequently in this class, are the normal force, which is the force between the force perpendicular to a surface. So I'm going to use that little symbol for perpendicular. And what it does is it basically stops objects from falling through surfaces. So if you ever put a mug or a book or a plate of food on a table and it doesn't fall through, that is because of the normal force. The applied force is any force that somebody applies. So if I push or pull something, that is an applied force. Next, we have friction, which is a force that is parallel to surface that resists the motion of an object. So if you've ever pushed something across the floor, if you've ever slid across the floor in socks and then come to a stop, the thing causing you to come to a stop is friction. The spring force is going to be the force due to a spring. And we have tension, which is going to be the force due to a string or rope. And these are our contact forces, the kind of thing that you can really see and feel. Our non-contact forces are a little harder to observe. And we're actually not even going to be talking about the last two at all past this video. So the strong nuclear force and the weak nuclear force, super interesting. Not actually something we'll cover in this class. But gravity and the electromagnetic force, we will. So gravity is a force that occurs because objects have mass. And masses are attracted to one another. The electric and magnetic forces occur because of charged objects. We will be getting much more in depth into gravity and the electromagnetic force in later units. In this course, we are mostly going to focus on our contact, or in this unit, we'll mostly focus on our contact forces, plus, of course, weight. So now that we've talked about forces, let's talk about Newton's third law. So Newton's third law is also known as the law of reciprocity. And the way that it's often written is that every action has an equal and opposite reaction, hence action-reaction. I prefer to think about it as every force has an equal and opposite force. Because it's not about, so the action reaction, Newton's third law, if I make a loud sound and you jump, I'm making an action, you're reacting. That's not Newton's third law though. Newton's third law would be if I was pushing on my table or on a wall, the wall is also pushing back against me. Or as we can see in this example, this boy is pulling with a tension force on the wall. So the tension force of the boy on the wall is going to be equal to the tension force of the wall on the boy. So the force of the boy on the wall is equal to the force of the wall on the boy. Similarly, the boy is pulling on this elephant with a tension force. And that's going to be equal to the tension force of the elephant on the boy. So again, force of boy on elephant is equal to the force of the elephant on the boy. And in general, we write this law as the force of object 1 on object 2 is equal to the force of object 2 on object 1. And one thing I want you to notice, our forces in all of these situations have the same name. So if I'm looking at the equal and opposite force of a tension force, its equal and opposite force is also going to be called tension. So one common misconception here is that the Earth has a gravitational pull on me, but I don't have a gravitational pull on the Earth. In fact, the gravitational pull of me on the earth is equal to the gravitational pull of the earth on me. So you may ask, okay, sure, but then why do I fall down instead of the earth falling up? The reason for this is that your mass is much smaller than the mass of the earth. Therefore, your acceleration is going to be much bigger than the acceleration of the earth. So the earth is not going to accelerate towards you in any noticeable sense because, quite frankly, it weighs so much more than you that your force doesn't really, that the force of gravity of you on the earth is really not going to do much to the earth. However, because you are much lighter than the earth, you're going to fall to the ground. So let's look at an example. I pull on a wagon with a force of 100 newtons. With what force does the wagon pull on me? So my applied force is equal to 100 newtons. Therefore, for me on the wagon. And that is going to be equal to the applied force of the wagon on me. Therefore, the applied force of the wagon is going to equal 100 newtons. There we go. So let's look at a second example. The Earth's gravitational pull on me is 1200 newtons. What is the equal and opposite force in this pair? So the equal and opposite force in this pair is my gravitational pull on the Earth, which is going to equal 1200 newtons. So there you go. Let's talk takeaways. Most forces are contact forces, but the four fundamental forces, those four forces in the right-hand column, are not. And second, most importantly, all forces have an equal and opposite pair. Its equal and opposite force has the same name. For example, the equal and opposite force for me pushing on the table is the table pushing on me. And there you have it, guys. That is Newton's third law.